Thank you. All right. Welcome to the deploying at scale with a single click talk. Sounds a little bit dramatic, the title. Maybe we'll try to keep it light enough. Let me quickly tell you who I am. Well, you already know my name. I'm from Belgium, the dark green spot here in the center of Europe. Best known for Belgian beer and chocolate and other tasty, yummy things. And odd-looking buildings, like an iron crystal magnified 65 billion times. I'm from a town very close to Antwerp, where we have a beautiful abbey and castles, all very nice. Except, of course, we have a massive traffic problem in Belgium. This is what happens when we have some snow. And smack in the middle of that, I started a company about 24 years ago now, called Cube Solutions. We do mostly PHP, but also a lot of Vue.js and a lot of Python nowadays with hardware stuff. And as most development companies, we have some DevOps, so that's what we're going to talk about today as well. I've been doing open source for a while, wrote a tool called PHP Compatibility. In case you don't know that one, you can use it to test to see if your code is compatible with the next version or a specific version of PHP. And hopefully we'll have a new release out that supports PHP 8.3 soon. And I've been doing talks like these for quite a few years now. Let's see who you are. Who here is a developer? Yeah, most of you are. Who here also has to do some DevOps on a daily basis or weekly basis? Okay, quite a few people. And finally, who has a project with lots of servers or maybe lots of devices running in the field somewhere? Okay, quite a few. Okay, all right. So, the title might be dramatic, but we're going to talk about something called orchestration, and I'm not going to use that word again because it basically means everything and nothing. I mean, if you look it up on Wikipedia or ask ChatGPT nowadays, it will tell you it's deployment, configuration, development, management, coordination, and a bunch of other things. So basically, it does all of our jobs and all of our colleagues' jobs at the same time. So I want to be specific when we're talking about deployment. We'll talk about deployment and orchestration. Yeah, that's just the grand word to unite them all, let's say. Short disclaimer. There are many strategies. I will talk about one, the one that we use mostly. And I'll add some alternatives along the way. I'll say, okay, maybe you can do it this way as well. But this is just one way of doing it, which might not match your needs specifically, but, well, that's why we're developers who can adapt. And what I'm going to be talking about works for various types of devices. We use it for a specific use case that I'll talk about, but it works for servers, it works for a network of Linux clients, it works for IoT devices. You can use this technology, these methods on Raspberry Pis, for example. It works on kiosks, payment terminals in the field, or whatever you want. So our initial goal was to set it up for deploying and updating devices that are running everywhere in the field around the world, from some train station to Waikiki Beach in Hawaii, literally. You see, we have a customer called Mobile Locker, and they provide mobile locker solutions, which, well, they call them units, actually. And in this case, they're at a festival or some kind of temporary event. But they also have fixed installations, for example, at the Belgian railways, so train stations, concert venues, airports, and so on. And, well, when I say they are sometimes in the field, that's sometimes really literally in the field. Anyway, they had a previous software supplier who made them a system that was Windows-based, built in something called Delphi. Anyone remember Delphi? Yeah, a couple of hands. Okay, it's not exactly a modern platform. It was originally built in 1995. Wait, PHP was built in, it's not exactly, it's kind of old as well, but at least we kept more up to date, let's say. So they installed everything manually, so USB stick with Windows, and then installed Windows and Windows updates, and then downloaded the exe, copied the exe from their USB stick and installed their program. And then their way of updating to a new version was, of course, TeamViewer. So they would log into that machine, blank the screen so that the customer who was trying to order a locker couldn't see anything, use a special key combination to exit the program. Of course, they had hidden the taskbar so that if the program crashed, the user couldn't do anything. Then they would copy a new exe file, start the program, and unblank the screen. So that was their way of deploying. Now, not only was their software quite unstable, but that way of updating is kind of tedious, of course, and it doesn't scale. It's okay because they only had 15 of these units in the field, but if you have 50 or 100 and you need to update like that, it just doesn't scale. So the challenge for us was to redevelop everything from scratch, and preferably not in Delphi. And we were told, yeah, over time we want to scale to maybe 100 units out there. So we decided to take a completely different route on every level possible. We said we're going to run Linux, not Windows. We're going to automate Linux installations so that we don't have to run through that process. And we're going to make sure that we automatically update system packages, the software that we write, the custom stuff, any Docker images, containers that we have, any configuration files that are specific to each individual installation. It all has to happen automatically. So how do you start with that? So let's say you want to install Linux. There's different options here, not just different distributions. We went for, at the time, CentOS Linux. Right now we're on Alma Linux, so we went the Red Hat compatible distribution way. There's different ways. You could do a manual install, which means putting in the USB stick that you got from an ISO file and then waiting until the thing loads and then saying, I want these packages and this root password and this disk partitioning and so on and so on. But you don't want to do that every single time. So the alternative is using something called Kickstart if you're on CentOS, or Precede if it's Debian. I think it's called Auto Install on Ubuntu. It's basically a configuration file that defines all the things I just mentioned, the packages and so on. And it will basically completely install your Linux automatically. And there's a thing in there that's quite nice. You can do pre and post scripting, which basically means the post scripting, for example, is shell script that runs after all your system packages have been installed. And there you have access to a set of basic tools, including Python, so you can do quite a few more advanced things as well. Next step is, of course, you could do Kickstart over the network using Pixie Boot. So if your device supports it, you plug it into the network, and if you have a server running that offers, usually through TFTP, a basic file to boot from, then you can actually do the entire Kickstart over the network. You don't have to be messing with USB sticks. And a more recent one, and that's mostly cloud-oriented, is called Cloud Init. It's a different kind of file. The syntax is slightly different, but the goal is the same. You still define which operating system there and then which packages you want installed. You can upload that to most cloud providers. Most of them will support it. Or you can use, for example, Proxmox as a virtualization layer, and that also supports it. So we were told you need to scale. In 2017, they told us up to 100. In 2020, they easily surpassed that. And last year, they told us, well, we want to be ready for thousands of them because we're scaling like crazy. So for us, at the time, we were doing the USB install thing. Yeah, that didn't work anymore, so that's fine for a few. It's not fine for the 1,000 or more. So we're currently going through the Pixie Boot evolution, looking at that. And so it involves going into the system BIOS of your computer. Luckily, some of them can be shipped with this pre-configured. And then either it will load a menu showing you, oh, do you want to install this operating system or that operating system? In our case, it'll be, do you want to install the test environment or a staging environment, or will this thing run in production? And then based on that, it will install Linux and the right configuration and so on. So after it's installed Linux, you of course need a way to identify what you've just installed. In our case, part of our kickstart, in our post part, we contact our central environment and we say, hey, please give me a name. So it's just an API call that we do, and it asks for a name, and so we get like these temp and then random characters. And so the unit that we're installing, the machine, the Linux machine, knows its name, and it shows it on the screen. That's great because we have a screen, because normally our users can order lockers on it. So that's really nice. But if you don't have a screen, for example, you're installing a network of Raspberry Pis that do sensoring somewhere or that control a door or something like that, then of course you need a different approach. So after you've installed that kind of device, well, the only way to really have a proper way of detecting it is either attaching a screen again or doing it on the network level, like looking at the MAC address, but then you need to have a managed switch. This is going to take us down a whole rabbit hole that we're not going to get into right now. But there are ways of doing that as well, of course. So let's imagine that you have your machine installed with Linux, you have it booted, you have given it a name, it has its basic configuration of system packages, and you have the IP address of the machine. Now, of course, you want to install software because although you've installed Linux packages, you don't have any custom stuff on it yet. You don't have anything configured yet. And there's quite a few tools that will help you with that part. I'm going to focus mostly on one tool called Ansible, but there are plenty of alternatives, and they all work in a similar way, I would say. There's Chef, there's Puppet, there's Salt, Terraform, a couple of others. We chose Ansible because it doesn't require you to install an agent on the target machine on which you're installing or updating or deploying your software or making configuration changes. It's very straightforward to start with, although you can make it extremely advanced as well, but you can grow into that over time. And it only needs an SSH connection. So all you need to have basically is in your Kickstart file, in that post section, if you can make sure that there's a public key in there, in the authorized keys file, then you can connect over SSH and you can run any command basically that you could run when you just SSH into the machine and start typing commands yourself. And that's essentially what we want to avoid. We don't want to do that anymore. We don't want to SSH in and type manual commands. We want everything to be unified, uniform in the same way. We want to run one command that does it all for us, basically automatic typing. It's not AI, but... and so, yeah, high level, Ansible has a playbook. The playbook does nothing more than, you can have multiple playbooks, of course. The playbook does nothing more than describe which roles you want to run. And a role could be something like, oh, I want to install packages or VPN, or I want to create users or remove users, or I want to install custom API software that we build. And then each of those roles can have a bunch of tasks. And I'm going to give a couple of examples. I'm not sure if they're very readable at the back. But for example, here we are going to install Docker. So there are a couple of built-in tools that you can use in Ansible, a couple of built-in tasks. This one uses the package task that's built in, and you provide it with which packages you want to install. And at the end, you say the state has to be present, which means at the end of this task, these packages should be present. If I were to change state from present to absent, it would remove those packages. And then there's a built-in, for example, for creating a directory called Ansible built-in file. I give it a path. I say it needs to be a directory. And I can say recurse true. That basically means in the case /etc didn't exist, also create that one. Or, for example, I could copy an Nginx configuration using a template file. And I'll show you later, there's a certain structure, and there's a template directory within each role that you can use to start with, copy templates to their final destination. And so that template will be copied, and any variables that are in there, because you can use variables to set certain specific things for that specific installation on that specific machine, can of course be replaced. There's also modules. For example, this is the community Docker module. And there's quite a few of them, and I'm not sure if this is going to work. This is not working. There's supposed to be a video here. Well, anyway, the list of modules, I scrolled through it, and it took me about a minute, I think, to scroll through it. And that's only the list of modules that's listed on the actual official Ansible website. And the video is now blocking me from proceeding. Ah, there we are. OK. So I guess it was playing, but not visible for some reason. OK, so this is an example playbook. So you can see here, it has a name. I am defining which hosts I wanted to run. And yes, you can have groups of hosts. For example, the web server group may have many hosts if you have multiple web servers. And then I'm telling it which roles to install. And I can even, at the bottom, you can see I can even import other playbooks. So you can reuse, inherit other playbooks, and so on. So let's imagine we run a playbook. What does that look like? Well, lots of output. Well, essentially, it's going to first say, OK, this is the playbook I'm going to be playing. And then it's going to start running tasks. And the first task is always going to be gather facts, which basically means SSH into the machine, check which operating system it is, check if it has the required tools installed, and then proceed. And then it's going to go through every single task. And you will get output saying either OK, which means, yep, it's fine, I did this task. Changed, which could mean I made a modification to a file. Fail, well, that's pretty bad. That means something failed. And usually, Ansible will stop unless you tell it, this task can fail, it's OK. And then there's also skipped. And skipped is one where it's, in case you have a whole task list and certain tasks don't have to run on certain machines, then it will just be skipped. And at the end, you get a play recap giving you a full summary of everything. So what if a task times out because we're using SSH? So if you get a timeout because, well, this machine is in New Zealand, for example, and it's kind of slow and it's on a 3G connection, or what if the task fails? Well, theoretically, every single task should be as atomic as possible. So you should be able to rerun that playbook, and it should give you the same result. It's just going to skip over certain things. Ansible will skip any tasks that don't need action, and it will update. Well, if you tell it to install packages, you can tell it to install packages 5 minutes later. Those packages are there, so it's just going to be a bit faster. So where do you run Ansible? Might be the next question, because there's two places where you can install it. In our case, we have a centralized environment where we keep track of all those Locker installations. We can see which of those machines are online, how fast they are. It's got a whole interface. I'm not going to explain what this all is. I'm going to take 2 snaps out of this. This is the first one. Those are the buttons at the top. So we have deploy new software and update system packages. The reason why we split those, that's another rabbit hole I don't want to get into now. The second section is we show, for example, OK, this is the software version that's currently installed on that machine. And actually, this is the most recent version we have. And then, yeah, you can see when they were last updated, of course. And if you click on Deploy New Software, what it's going to do is, well, from our centralized environment, we decided to run Ansible on our server here, because that requires only one installation, one place to manage and monitor, one place also to see live feedback. And so we SSH automatically to those machines. we get the feedback back, and we even show it live in the browser. It scrolls automatically so we can see. And the customer likes that because sometimes they're a bit impatient. They click update, and then they're like, why is it hanging? Why can my customers not continue ordering stuff? And then they see, oh yeah, it's doing a very slow update because the 3G connection is very bad or something like that. So that's the main advantage. You have a central way of seeing it. The disadvantage, of course, if the connection's very bad or the connection gets interrupted, then at some point the SSH connection is going to be cut and the whole Ansible process will fail. And so you have to restart it again and again and again. And so we have a couple of train stations, for example, where the locker system is underground. There's a lot of steel and a lot of concrete above it. The 3G is almost non-existent, and then sometimes you have to deploy 10 times. Not really ideal. What we do actually is take it one step further because we sometimes want to prep a lot of them already. So we have a queue in there, and then we run a bunch of consumers so that we can actually, when we do a big release, deploy like 100 computers at the same time. And so each one of those consumers will then SSH to the right target machine. The alternative to running it on a central environment is, of course, running it on the machines themselves. So you install Ansible on each machine, and then essentially you could have a central environment that says, okay, machine number 1, you need to update. And then they will pull from the queue and say, oh, I need to update. Okay, I'm going to just start updating with Ansible locally. Of course, in that case, you need on each of those machines, you need just not only Ansible installed, but the entire repository, the playbook, the roles, the tasks, and all that. And you need to keep that updated. It needs to be in sync, because otherwise you're going to be installing a different version on each machine. So that's a bit of the downside. The other thing is, of course, it becomes harder to keep track of what is really going on, whether it's successfully deployed, unless you make another callback, of course. But it's also harder to have a real-time view of what's going on. Another downside, Another downside of this is that this only works if each machine can be configured independently from each other. Now, you might think, well, why would I not be able to configure machines independently? Well, a good example is clusters. If you have a cluster set up, if you have a cluster set up, then logically you want to install that cluster in one go. Ansible luckily has a thing called an inventory folder, and you can group different hosts together in groups, and you can say, okay, these belong to one cluster. And how do I put this? Yeah, you can actually tell it to run all your configuration tasks simultaneously on a number of hosts. What will happen is it will run it simultaneously, but still each task will be run after the other. But it will not continue running it will not continue on any host until all hosts have completed a specific task. That way you're certain that they're all in the same state. So if anything goes wrong during that process, well, they will all be cut off at that point. Now, logically, in the case of, let's say, MySQL replication, there is a difference between what you want installed on what we used to call a master, the primary, or what you have on the secondary. Because the primary, for example, needs to make a user so that the secondary can connect to it. So for that reason, there's the concept of variables. And variables can be configured in Ansible globally, on a group level, on a host level, or even you can even use environment variables. How does that look? Well, this is a variable, for example. We have a task main here, and we're going to verify that certain packages are installed. And I use a variable packages, and that comes from Within the same role, there will be a directory vars, and I have a variable packages with a bunch of packages that I want installed. Another example, maybe I have a users role, and in there I have variables with users that I want to create, but also users that I want to delete because those people don't work here anymore, so I want to get them all removed. And I want to be able to say, okay, this person was fired, maybe. I want within 5 minutes on all those hundreds of machines, that user needs to be deleted. Instead of having to log in to 100 machines, I can just run an Ansible role and basically say, okay, the state has to be on that user has to be absent. So yes, remove this user. And in this case, I'm iterating over the list user deleted users. And then another example is replication, for example, on MySQL. Here you can see a command to start replication. And I give it a password, and here I use, I say when the cluster secondary is in the group names. So for example, there will be, group names is a variable that's always present in Ansible. And so if this machine is defined as a cluster secondary, then I will start replication. So variables can be used in many different ways. It could get very complicated at some point. You can also use the output of a task and store it in a variable and then use that in a next task, for example. So lots of options there. But you can start slowly and gradually build it up, of course. Now, as I mentioned before, if you deploy a cluster, for example, you're going to do that to a group of hosts. So you're going to run tasks at the same time in parallel. So you can use Ansible to deploy anything on 1 machine, 2 machine, 100 machines at the same time. It doesn't really have a hard limit. The default limit is 5, but you can override that. And it works really well. And you can see in a single screen, in a single log, for example, here, okay, we're doing demo machine 1, demo machine 2, and demo machine 3 at the same time. And again, you can see live what is going on every step of the way. Now, I'm coming back to what I mentioned previously. Let's imagine that one of these machines is either in New Zealand, or maybe it doesn't have an SSD drive, it has an old spinning disk, or maybe it's swapping a lot. Anyway, it's kind of slow. Then what you can get is that everything works fine until, for example, you run Composer install. And now Composer install on demo machine 1 is done after maybe a minute. And then demo machine 2, another minute and a half. And then we're waiting for demo machine 3. And we're waiting maybe 5 minutes. And so as long as that task is not complete, none of them will continue. So that's something you have to keep in mind if you're doing deployments, that if there's a task that brings down a machine in terms of service to your user, that it will affect every single one of them, and they will not be able to continue until all of them are done. Again, in most cases, it's not an issue, but there are cases where 2 tasks have to quickly follow each other. So that's something to keep in mind then. What does the folder structure look like? Well, this is a part of what a folder structure could look like. Because if I show you a complete one like we have, it's many, many, many levels deep. But for example, you would have inventory files, one for production, one for staging, for example. Then you would have a directory with group variables for the different groups, one for the web server, one for the database server, and so on. And then each host can also have its own variables. And then you have all the roles. Here you see a common role with a task file main. It's all in YAML, of course, here. And then, for example, we have an Nginx task. And that Nginx task also has a template that we're going to use within that task to copy it in the right place. And then at the bottom, you can have one more playbooks, depending on what you want to do. Now you might think, well, hang on, I'm not deploying Raspberry Pis, I'm not deploying servers, kiosks at the other side of the world, I just have to have a bunch of servers. That's all I have really. Well, that's exactly what tools like Ansible were originally built for. Deploying in a consistent way on every single server. Every single server that is part of the same group needs to be deployed in the same way, and every single time you do a deploy, it should deploy exactly in the same way. Put the same configuration files in exactly the same spot, update the same files, and so on. And in the same way, you want to deploy to a test environment, to a staging environment, to a production environment, knowing that if it runs on test, if it runs on staging, if you deploy that same way on production, it will run. And that's kind of the basis for these types of configuration tools, like Ansible and Chef and all the others. This is how it started. And then, of course, people started using it for other stuff as well and deploying clusters of Raspberry Pis and things like that. On top of that, if a server crashes, well, all you have to do is reinstall the operating system and run Ansible. And theoretically, it should just, with your playbook, install all the packages, put your configuration files back in place. Worst case, you have to restore maybe a database backup if that was a database server. But everything else should run exactly the same way again. Same thing if you want to scale up. Let's imagine you're running on one machine today. Tomorrow you want to run a second one. Well, you add an additional host into the group of your web servers, for example, and you run Ansible, and it will install. Now, you might have to run a load balancer in front of it then if you have two machines, but yeah, that's a different thing, of course. But if you go from 2 to 4, or suddenly you get a spike and you need to install 20, again, same kind of story. You just add it to the host, add the host to the group, and you run Ansible. Now, of course, it's essential also to have some way of logging, some way of getting feedback so that you can verify that the tasks were actually completed. The playbooks, in case of Ansible, were completed. In our case, what we do is we call the central platform, report back in and say, yep, I installed, and I'm now running on this version, and all of these packages were installed. And that way we know that we can report to the customer, okay, it's fine. And the main reason for that is, yeah, as I mentioned at the beginning, it can start very small and you can keep it up to date easily, but once it grows to the point where you have hundreds of devices, then you don't want 50 of them running on a version that's 2 weeks old, 50 of them running on a version that's 1 week old, and oh, we have another one. It was offline for 6 months, and now it's come back online. But it should be fine, right? Everything should be still working. Well, maybe your APIs have changed. Maybe it needs some kind of update that won't make it work at all anymore. So having it call back, having a way to see where you are, allows you to, well, scale up, essentially. That's all for today. Any questions?
Thank you very much. Has anyone got any questions? And I'll bring the mic over. I mean, I have got 8 questions. Well, how easy is it to set up tests for your Ansible scripts, to run them in CI or something similar?
So we actually run everything that we do in our CI, and the other way around, we also use the CI to run the installation of our servers through Ansible. You can set there's a whole way of setting up, how do I describe this? There is a test integration suite for Ansible as well.
Okay.
So you have a way of defining not just testing whether your tasks are properly defined, because of course you have syntax highlighting and checking of your YAML. But there are test suites that you can run. It just depends on what you're trying to accomplish. But yeah, so in your CI, we run a whole set of syntax checking things, but it's kind of hard to validate unless you have like a VM that you automatically deploy and then verify if everything was done. But theoretically, Ansible should check by itself, did I successfully execute every task?
Okay, thank you. Anyone got any other questions? Hold on a sec. I'm going to do a lot of steps today.
Regarding the software you have shown for the device management, how is that interfacing with Ansible? Does it write config files or does it write to the inventory file, or how do you handle that?
Sorry, could you repeat for a moment? I was distracted there.
No worries. Regarding the interface you shown, the web interface for your device management, how does that interface with the Ansible inventory? Does it write the inventory files? How are the variables handled?
So essentially, what we do is we clone the latest version of, or the correct version, depending on staging or testing environment, of the repository, and update the inventory file. And we do that for every single installation separately, because it could be that somebody says, okay, I want to update these 3, deploy. That could run, in some cases that could run for a little while if it's got a slow connection. And in the meantime, we could be publishing a new version, so it's independent. So it's all in separate subdirectories that we also store for a while so that we can go through the logs afterwards. And so that we can compare, okay, this went wrong. Why did this go wrong? And we can see, oh, in the repository, we were using that host and that role was called and so on. So yeah, it's basically we copy the repository on disk every single time.
Okay, thank you.
And clean up afterwards, of course, after a while.
Thank you.
Thank you. Any other questions? Oh yeah, some at the back.
Hello. Oh, bit loud. How do you sort of test when it goes into production? I know you say you'll go to test and then to staging and then into production, but with best endeavors, things do go wrong from time to time. So what do you do to stop a CrowdStrike sort of moment? You know, how do you get a canary out there or something? Do you test with a few devices first and then do a full release afterwards?
Yeah. Obviously, yes. So we don't, for example, immediately update the installations on the Belgian railway stations, because there's constant flow there, and if things go wrong, then yeah, that's a bad situation. Or we don't do it at like a rock festival where there's 80,000 people coming in, where we have a big cluster installation. So we've noticed that anything we deploy on staging is usually a very good representation, because we have, and the customer actually has an entire staging room where they have every single possible combination of hardware devices set up. And so they can do a very good test. But as you said, yeah, if you deploy in production, maybe you forgot to test whether the latest 50 euro note actually works on that note reader, and now it's giving a different error back, and yeah. So usually what they do is they will, on the first day after a big release, they will deploy to 1 machine, 2 machines, 3 machines, and then at some point they will be like, okay, now let's do these 10, and then they do them in batches if everything works out. If not, well, either we need to do a hotfix if it's really something really bad, but then how the heck did it get through staging? Or yeah, we can always roll back to a previous release.
Brilliant. Thank you very much. We're out of time for questions now, but are you happy if people have got questions, they can come find you at the conference?
I'm around all day.
Brilliant, yeah. Speakers love being asked questions and stuff like that, so don't be afraid to go and ask them around the hallway track and anything if you're inspired by what you've heard by any of the talks today. So can we have a big round of applause for Wim, please? Thank you.
Thank you.